For this video, we will be discussing about electrochemistry. Before anything else, this is our learning objectives and our conceptual framework. Now, let's start the discussion. Have you ever wondered about how, when, and what are the symbols and information behind these values? The answer is one word: electrochemistry. Come on, listen, and let's dig deeper. If we heard the word electrochemistry, we will come up with the idea that it is a combination of the word electricity and chemistry. Well, we got the point. Electrochemistry is defined as the branch of chemistry that examines the phenomena resulting from combined chemical and electrical effect. In other words, it deals with chemical reactions that produces electricity. Many metals may be purified or electroplated using electrochemical methods. Devices such as automobiles, smartphones, electronic tablets, watches, and calculators, and many others devices that uses batteries for power. So what is electrochemical cells? Electrochemical cell is a device that can generate electrical energy from the chemical reactions occurring in it, or use the electrical energy supplied to it to facilitate chemical reactions in it. These devices are capable of converting chemical energy into electrical energy, or vice versa. A electrochemical cell typically consists of two electronic conductors that can be called as electrodes. These two electrodes are cathode and anode. When we say anode, it is at which electrons are lost, or the oxidation process. And cathode is the one at which electrons are gained, or the reduction. Electrochemical cell also consists of ionic conductor that is called electrolyte, which is often a metal wire such as a copper wiring. There are two types of electrochemical cells, namely electrolytic cell and galvanic or voltaic cell. Galvanic cell is used to convert chemical energy into electrical energy, just like the batteries in your television remote. Whereas electrolytic cell is used to convert electrical energy into chemical energy to carry out a chemical reaction, and can be used for electroplating, which is a process of coating an electrically conductive object with a thin layer of metal using an electrical current. The story of electrochemistry begins with Alessandro Volta, who announced his invention of voltaic bulb, the first modern electrical battery in 1800s. Volta had built the voltaic bulb to challenge Luigi Galvani's claim to have demonstrated that animals produce electricity. According to Volta, Galvani's result came from his use of two dissimilar materials connected by a moist conductor, which is a frog's leg. Volta reproduced his configuration in his new invention, which is consisted of pairs of zinc and silver discs connected by a brine-soaked cardboard.
Good day everyone, my name is Christine Aloy and my topic is all about the equation and method of electrochemistry. So the most common equation in electrochemistry is what we call the Nernst or Nernst equation. So in electrochemistry, the Nernst equation is an equation that relates the reduction potential of an electrochemical reaction to the standard electrode potential, temperature, and activities of the chemical species undergoing reduction and oxidation. And it was named after Walther Nernst, a German physical chemist who formulated the equation. So Nernst equation also is an equation relating the capacity of an atom or ion to take up one or more electrons measured at any conditions to that measure at standards of 298 K and 1 molar or 1 atmospheric pressure. So let's proceed to Nernst equation for single electrode potential. The formula is being shown. So where E cell is equal to the cell potential of the cell, the E standard is the cell potential under standard condition, the R is the universal gas constant, the T is the temperature, the N is equal to number of electrons transferred in the redox reaction, the F is the Faraday constant, the Q is the reaction quotient. So let's proceed to the example using our formula.
The standard electrode potential of zinc ions is 0.76 volts. What will be the potential of a 2M solution at 300 K?
So let's proceed to the solution. So the Nernst equation for the given condition can be written as follows. So where E standard is equal to 0.76 volts, the N value is 2, the Faraday constant is 96,500 C per mole, and the Mn positive is the 2M, and the R value is constant 8.314 J per K mole, and the temperature is 300 K. Substituting the given values in Nernst equation, we get the following. So, therefore, the potential of a 2M solution at 300 K is 0.769 volts. So, always remember that the Nernst equation can be used to calculate the following. So, number 1, single electrode reduction or oxidation potential at any conditions. Number 2, the standard electrode potential. Number 3 is comparing the relative ability as a reductive or oxidative agent. Number 4 is finding the feasibility of the combination of such single electrodes to produce electrical potential. Number 5 is the EMF of an electrochemical cell. Number 6 is the unknown ionic concentration. And the last but not the least, the pH of solutions and solubility of sparingly soluble salts can be measured.
Now let's proceed to electrochemical methods. There are 3 types of electrochemical methods. First one is potentiometry methods. This measures the potential of a solution between 2 electrodes. The potential is then related to the concentration of one or more analytes. The cell structure used is often referred to as an electrode even though it actually contains 2 electrodes, an indicator electrode and a reference electrode. Potentiometry usually uses electrodes made selectivity sensitive to the ion of interest, such as the fluoride selective electrode. The most common potentiometric electrode is the glass membrane electrode used in a pH meter. The second method of electrochemical method is voltammetry method. That is used in the applies of constant and varying potential at an electrode surface and measures the resulting current with a free electrode system. Voltammetry, with its variety of methods, constitutes the largest group of electrochemical methods of analysis and is commonly used for the determination of compounds in solution. The last method is the colmetric method, which is based on the measurement of the amount of material deposited on an electrode in the course of an electrochemical reaction in accordance with Faraday's laws. A distinction is made between colmetry at constant potential and colmetry at constant current.
Good day everyone, my name is Michael Martinez and today we will going to tackle about electrochemical reaction. So let's start. Chemical reaction either absorb or release energy, which can be in the form of electricity. Electrochemistry is a branch of chemistry that deals with the interconversion of chemical energy and electrical energy. Now let's proceed to voltaic cell. Voltaic cell is an electrochemical cell that uses a spontaneous redox reaction to produce electric energy. The voltaic cell consists of 2 separate compartments. A half cell is one part of voltaic cell in which either the oxidation or reduction half reaction takes place. The left half cell is stripped of zinc metal in a solution of zinc sulfate. The strips of metal are called electrodes. An electrode is a conductor in a circuit that is used to carry electrons to a non-metallic part of circuit. The non-metallic part of circuit is the electrolyte solution in which the electrodes are placed. A metal wire connects to 2 electrodes, switch open or close the circuit. A porous membrane is placed within the 2 half cells to complete the circuit.